Au Jobe utalaga metse. Wadibusa. Rao solva. Rao pasa. Ratana ka metse rao beta ka plat. It's maths plata. We are celebrating mathematics as we prepare for our final examination. We have less than 10 days left. We are busy with Euclidean geometry, and we have demonstrated the power of what? Diagram analysis. We have demonstrated the power of what? Diagram analysis. So on the 4th of November, we are all going to do what? Diagram analysis. Where? On the question paper or answer book? Wonderful. Candidates, please come and write the answers for us. Let's give her a hand. Good. We are now going to answer question number. Right. The ball is in your court. Write it. Yes?
So the question is asking for three other angles that are equal to 65 degrees. So from our diagram, we have identified three angles, which is this one, and this one. So let's start with angle S1. So as Jobe told us, we start from known to unknown. So we're going to say angle A is equal to angle S1. So the reason is for us to make angles. And then the parallel length is AN parallel to SB. Therefore, angle S1 is equal to 65 degrees.
Yes.
And then we have angle N1. So we're going to start from known as well. A is equal to angle N1. Why? Tan angle. Therefore, angle N1 is equal to 65 degrees. We have another tangent, meaning we can also apply the tan theorem. So we're going to say angle A again is equal to y tan chord. Therefore, angle y.
Right. Thank you so much. Let's give her a hand once more. Let us read the question and see if we have answered. As candidate for V goes to the board. Let's quickly read the question.
Write down with reasons three other angles each equal to 65.
Each equal to?
65.
Right. So have we all collected the points? Yes. Next question for V. Right, continue.
Okay, so we're going to place both our fingers here.
We get the idea, ne? Yes, the left one at what? Y. The right one at? The left one at? At V, ne? At V, yes, the left one. Let us demonstrate that on our circle. The left one at V. Again. The right one at? Y. Yes, continue, my girl.
We're going to move them to see which angle they subtend. It's going to be angle N1. And then we're also going to see we're also going to see which other angle they subtend. Which one is it going to be?
S1. S1.
So,
yes, continue.
N1 and angle S1. They are equal, right?
Yes.
We prove that in 2.1. Which means that it's going to be converse angles with the same segment.
Yes. Good. The reason? Equal to what? Write the value. Equal to what? 65 degrees. Do you agree? Yes. Let's say it louder. Do you agree? Yes. The word converse means the reverse. Let's give her a hand. Yes, Zippo. Then we do the last one. Then we take another breather. Candidate Zippo will do the last one. Let us read the question for him.
Prove that triangle ASN is isosceles.
Prove that what?
Triangle ASN is isosceles.
Wonderful. The ball is in your court, my boy.
So question 3.2.3, we are required to prove that triangle ASN is an isosceles. We know for an isosceles we have two sides that are equal, or two angles that are equal. So we're going to look for another angle, either S3 or N2 that is equal to 65. Since our candidate proved that VYSN is a cyclic quad, we're going to look for other angles on the cyclic quad. And then we're going to find that S2 is equal to 65 degrees because of angles in the same segment. You can see that the code NV subtends the same angle.
Do you agree so far?
Yes.
Good.
So we're going to say angle S2 is equal to 65 degrees. And then we know that we have parallel lines.
We need what? The reason. Why are you saying S2 is 65? Yes.
So I'm going to look for N3 using alternate angles. We know that we're given the parallel lines AN and S1. So we're going to, these two are alternating, S2 and N3. So therefore this is 65 degrees. And we have to mention the parallel lines. So we're going to say N3. Angle N3 equal to 65 degrees. Alternating angles. Parallel lines is AN. Parallel to SB. And therefore angle A and angle N3 are equal, and we wanted to prove that one of the two angles in the triangle is equal. So we're therefore going to say angle A is equal to angle 3 because they are both equal to 65 degrees. We have therefore proven that ASN is an isosceles triangle. And the reason is opposite.
What is the reason?
Sides opposite equal angles.
I can't hear you.
Sides opposite equal angles.
Because the angles are? Which angles are equal? Angle what? Did he do it correctly? Yes. Let's give him a hand. So we have answered all the questions under Euclidean geometry. So as we go to the examination, before we take a short breather, make sure that your diagram analysis is perfectly done. Do you agree, candidates? Yes. We are going to take another breather. Then when we come back, we continue. Thank you so much.